Welcome back. Let's take a moment to discuss cones. Cones have a circle for a base. They have one base, and that base is circular. And because of that, we can think of it as a circular pyramid. That will allow us to use the same formula that we use for the surface area of a pyramid. It does have a true height, which would be, in this example, right here, from the center of the circle base all the way up to the apex of the cone. That's also called the altitude. And then the slant height goes from the edge along this slanted surface up to the apex. So the true height and the slant height. In this example, we have the radius of the circle given. So the radius is 12. We have the true height or altitude given as 16, so height is 16, but we don't know the slant height. We're going to use that Pythagorean theorem to find the slant height. 12 squared is 144, plus 16 squared is 256, and then that's going to equal the slant height squared. This true height does make a right angle with the base, so that's why we have a right triangle, and that's why we're using the Pythagorean theorem. 144 plus 256 is 400, and if we take the square root of both sides, we find that the slant height is 20. Now our formula for for surface area of any pyramid is perimeter of the base times the slant height divided by 2 plus the area of the base. Well, we need to tweak this formula just a little bit for our shape here. We have the perimeter of the base, and the base is a circle. So the perimeter of a circle is also known as the circumference of that circle, and it has a formula of 2 pi radius. Then, of course, we still have the slant height, and we have the divide by 2. And then next to that we have b, which means the area of the base. Well, if it's a circle, that would be pi times the radius squared. So that's our adjusted formula for the shape that we have. We can put in some values, but as I do that, don't forget that you can cancel out these 2's. So that 2 and that 2 are going to cancel each other out. And we have pi, and we're going to use 3.14. Some teachers and textbooks and videos will use the pi button on their calculator or certain other amounts of the decimal places, but I use 3.14. The radius is 12. The slant height we calculated to be 20 plus pi, 3.14, and then the radius squared is 12 squared. Now, I always encourage you to make sure you don't mess up on the order of operations. So you want to do those things first before you add 3.14 times 12 times 20. It's 753.6. And 3.14 times 12 squared, I get 452.16. And then our final total is 1,205 point, I'll just leave it like that, 0.76. You can round however you need to. This will be units, and it is surface area, so squared. In example number 2, we're going to do two things here. We are going to find the decimal value just like we did in this first example, but we're also going to get something else. We're going to get our answer in terms of pi. I'll show you that in a moment. This cone is turned sideways now, so this distance is not a slant height or anything like that. This is the diameter across the circle. So the diameter is 28. That means the radius would be half of that, 14. And the slant height is given to us at 17. We're going to start the same way we did before. Here's our surface area formula in general. And then for the circular base, I made my adjustments here, and that follows what we did in example 1. So I'll pick up from there. 2's, they're going to cancel each other out. And put in our values, 3.14 times the radius of 14 times the slant height of 17 plus 3.14 times the radius squared, and we'll type those in. 3.14 times 14 times 17, 747.32 plus 3.14 times 14 times 14, and we get 615.44. If I add those two together, I get a total of 1,362.76, and I'll leave it like that. We could round it differently if we want to, and that's going to be units squared. Now, sometimes you'll see this phrase in terms of pi, and also sometimes you'll see the term exact. Now, all that means is that when we do our calculation, we do not want to have 3.14 involved, because that's an approximation for pi. Instead, what we would do at this line of the problem, instead of putting in 3.14, we would leave a pi symbol, and then everything else would be put in just the same. And then we would have a pi symbol there, and everything else would be put in the same. Now what happens in the following lines is 3.14 is not part of what you put in the calculator. You just put the other values in. This would 14 times 17 would give you 238, and you would have pi, and 14 squared would give you 196, and you would have pi. Since they both have pi, we can add those together, and we would end up with 434 pi, and it would be square units. But our answer is in terms of pi because it has pi as part of it. We do not put the 3.14 in there. These two values are identical to each other, but they're just written in different ways. See you next time.